Students, do you see my screen?
Yes, sir.
Okay, fine. So last class we were discussing random variables. So random variable is associated with some random experiment. Random experiment means an experiment, an act of describing certain act of describing some particular phenomena. So a random experiment is that experiment whose possible outcomes are known to you, but which possible outcome is going to happen in a particular performance, that is not known. For example, if you throw a die, then either it will be from 1 to 6, but which one will be appearing, what will be the face value, that you do not know, but it will be from 1, 2, 3, 4, 5, 6, one of these 6 values. So that is a random experiment. That is a random experiment. So let us quickly summarize. So random variable is associated with random experiment. For random experiment, the set of all possible outcomes, that is known as sample space. So a random variable is a real valued function from sample space to real line. So we have seen some example how to formulate random variable. It can be defined several ways, but which particular random variable will be helpful to solve real life problems or the problems you want to solve? Which particular random variable will help you? That will be depending on the experience of the experimenter. So here we are going to consider some well-known random variables which are frequently used. So first we'll classify the random variables into two groups. One will be continuous random variable and another set will be discrete random variable. So let me write down in short. So this is a random variable. Random variable. It is not a variable, it is a function. Okay, real valued function from sample space to real line. Each possible outcome of an experiment is associated with a real number. So this is a bit confusing. It means argument. The argument of the function is a sample element of sample space. So it is a set. Okay. So random variable are classified into two groups. One will be discrete random variable and another will be continuous random variable. So discrete random variable and another type is continuous random variable. What are the examples? So a random variable which takes finite or countably finite number of, see, which one is called discrete random variable? A random variable which takes or assumes or which takes finite or countable number of values. Okay, so what does it mean by that? So if x is a random variable, then x will be taking the value x1, x2, x3, x4 and so on at discrete points. So there will be a countable number on the real line. So if this is the real line R, then there will be a countable number of points on this real line, which are the images of the random variable. So these points are discrete points. You can separate them from each other. Okay, so that is a discrete random variable. So the type of the random variable which I have defined here. You see, x of capital X of x equals to 0 if the face value of the die is even, and 1 if the face value of the die is odd. So you see the random variable is taking only 0 or 1 value. So only two values are there. So we can separate these two values. So this is an example of discrete random variable. The first one, x of x is equals to x. So how did I define this random variable? This is the face value of the die. So it is also having finite set of outputs 1, 2, 3, 4, 5, 6. So this random variable, if I call it 1, then that is also discrete random variable. So if the image of the random variable consists of countable or finite number of points, then that random variable is called discrete random variable. Okay. On the other hand, what is continuous random variable? If the random variable takes all possible values in a given interval. So a random variable which takes all the possible values in a certain interval. Okay, so that is continuous random variable. Now we are going to consider some special discrete and continuous random variables. Okay, so one of the example I can give you, for example, if you consider the temperature of the weather. So temperature of the weather, what are the all possible values? So it may be, suppose we are talking about temperature today at Prayagraj. So it may be from 10 degree to 20 degree, and any value is possible. Theoretically, any value is possible. 10.1, then 10.11, then 10.111. Even there are numbers between 10.1 and 10.11. In fact, there are infinitely many numbers, uncountable number of points between 10.1 and 10.11. So if this possible output will be any number from 10 to 20. So that is why that random variable will be a continuous random variable. Is it okay? So what we are going to do, we are going to study few well-known random variables. So let me write them. Discrete uniform distribution, first we'll consider discrete random variable. Okay, so let us define few things: expectation or mean and variance of random variables. Students, is it okay so far?
Yes, sir.
Yes, sir. Okay, so we are going to define certain terminology which will be expectation or mean and variance or and standard deviation for random variables. So here, in case of discrete random variable, we have seen, you see, if you consider the previous examples here, while we are tossing two coins together, and suppose x is the random variable which counts the number of head in each possible outcome. Okay, so then you see we are tossing two coins together, and S is the sample space and X is the random variable from S to R. How the function, the random variable capital X is defined, number of heads appearing in each possible outcome. So X of HH is 2, X of tail head and X of head tail equals to 1 and X of tail tail equals to 0. So this is the random variable X, which is taking possible values 0, 1 and 2. And what are the corresponding weightage for taking those values? What are the corresponding weightage to taking those values? 0 एज्यूम करने के लिए weightage कितने हैं?
1/4, 2/4.
1/4. 1 को एज्यूम करने के लिए weightage है 2/4. So और 2 को एज्यूम करने के लिए weightage है 1/4. So these are the called weights in case of discrete random variable. Weight and so or mass. So let me use word mass. So this is called mass of the random variable. So first here 0, 1, 2, these are the possible outcomes of the random variable, and these values here, these are called the mass of the possible outcomes. What is the weightage of each possible outcome? That is denoted here. Okay. So what will be the sum of the all the weights? Can you tell me? Whatever random variable you take for a given experiment, what will be the sum of all mass or all weights?
1.
Total probability. Total probability. So total probability is always 1. Okay. So anyway, so let us write down. So this is definition. First we'll consider discrete random variable. So it is called probability mass function. How the output and its corresponding weights or mass are distributed. How the mass are distributed corresponding to each possible outputs. That will be called the probability mass function of discrete random variable. And if the probability mass function is known to you, then you can find out the probability of all the events. All the events means any question which you pose, that is an event. So if the probability mass function, how the mass are distributed for each possible outcome, if that is known to you, then you can use that information to find out the probability of any event. Okay, so that is what we are going to define. If X is a discrete random variable, so if capital X is a discrete random variable, then this notation X equals to x1, x2, x3, इसको थोड़ा स्पेस देके लिखते हैं. ओके, X equals to x1, x2, x3, x4 and so on, and here p of x equals to xi. So that is the mass. So it is p1, p2, p3, p4 and so on, is called probability mass function of the random variable X. Mass function of the random variable X. So few observation you can see. What is Pi? What is Pi? What can you say about Pi? Pi is what? Probability at x equals to xi.
X.
What does mean by that? Probability of all those events, probability of all those elementary events which assumes the value xi. Okay, so what is x? Remember, x equals to xi is an event. It is a subset of, it is a subset of, it is a subset of sample space. How? This is all those events which are mapped to xi, all elements of sample space which are mapped to xi. ओके, सो सैंपल स्पेस के वो सारे एलिमेंट्स जो xi पे मैप्ड है, सो दिस इज ए सबसेट ऑफ सैंपल स्पेस. सो व्हाट इज द प्रोबेबिलिटी ऑफ दैट सबसेट टू बी ट्रू? ओके, so p of xi, so what is that? So this is always greater than equals to 0, yes or no? Pi of any event
Yes,
is
sir.
greater than equals to 0. Okay, so and what is the sum of all pi?
Total probability.
1. So this is also known to you, summation over I pi equals to 1. So if any mass function type things are given to you and you have to deduce something, then these two results should be known to you. The sum of all the probabilities are 1 and pi is probability at x equals to xi. Okay. Is it okay?
Yes,
So
sir.
remember, it is called probability mass function. In case of discrete, the probability, how the probability are distributed for each possible outcome, that is known as probability mass function. In case of continuous random variable, it will be probability density function. It will be given in terms of certain continuous function. I should not say continuous function, it may be discontinuous, but it will be given in terms of certain function. So that is why that will be called probability density function. Anyway, so we also will be considering that. So few more results we are going to consider is what is the next is, so it was probability mass function, next is distribution function, cumulative distribution function. So this particular function is called cumulative distribution function. X be a random variable, x be a random variable, then the function defined by, then if you define a function capital F of x is equals to probability of random variable x taking the values less than equals to small x. This particular function is called distribution function, cumulative distribution function. Cumulative, these are the certain terminology used by statistician, so you must have to follow that, you cannot ignore that. Cumulative distribution function. What does it mean by that? So what is the probability? What is basically that tells you in case of discrete random variable. If I ask you in this particular example, if I ask you what will be f of 1, what will be f of 1? By definition, this is probability that the random variable x takes the values less than equals to 1. Following that definition, what was that? You see, f of x is probability of capital X less than equals to small x. So that is what I have written. What is f of 1? Is equals to probability of capital X less than equals to 1. So what are the possible outputs? 0, 1, 2. So what are the values? What are the values attained by x less than equals to 1? 0 and 1. So this will be probability at x equals to 0 plus probability at x equals to 1. No other possible outputs are there which will be satisfying x less than equals to 1. Okay. So basically, we are finding the probability of all those events which are mapped to a real number less than equals to 1. So in the current scenario, which you can see on the screen, only 0 and 1, these two outcomes are less than equals to 1. So what will be the probability up to x less than equals to 1? So it will be probability at x equals to 0 plus probability at x equals to 1. So this will be 1 by 4 plus 2 by 4. So this will be 3 by 4. So this is f of 1. Similarly, you will have few other f of 0. What will be f of 0? F of 0 will be 1 by 4. What will be f of 2? Probability up to the point 2. So how much probability?
1 by 1.
1 by 4 plus 2 by 4 plus 1 by 4. F of t is probability x less than equals to 2. So this will be probability at x equals to 0 plus probability at x equals to 1 plus probability at x equals to 2. So if you add all them, you'll get 1 by 4 plus 2 by 4 plus 1 by 4. So that is 1. What will be probability of x? What is f of 3? F of 3 is by definition probability of x less than equals to 3. So that will be same as 1. 3 से पहले कितने वैल्यू एज्यूम किया रैंडम वेरिएबल ने? 0, 1 और 2 को. 0 को एज्यूम करने का प्रोबेबिलिटी था 1, 1 को एज्यूम करने का 1 by 4, 1 को एज्यूम करने का प्रोबेबिलिटी था 2 by 4 and 2 को एज्यूम करने का प्रोबेबिलिटी था 1 by 4. So if you add all them it will be 1. So this is also 1. Similarly f4, f5, f1. F2.5, f2.1, all those things will be 1. So you have to add all the probabilities up to that point. So that is cumulative distribution function. What is the total probability up to that point? Cumulative means what? You are collecting. So what is the sum of the probabilities up to the point small x? Okay. So this is called cumulative distribution function. So can you tell me what will be f of minus infinity or limit x observation? These are the observation. So in case of discrete random variable, this will be summation over xi less than equals to x, probability at x equals to xi. So this is f of x in case of discrete random variable. आपको बहुत सारे possible output find करने होंगे जो x से छोटा हो, and all those xi you have to find out the probability and you have to add them. Okay. So if you want to find out the cumulative distribution function for discrete random variable, you will have to find out all the possible outputs which are less than equals to small x, and at all those possible outputs you find out the probability and then add them. So this is the cumulative distribution function in case of discrete random variable. So what are the possible observations? What is this value? Limit x tends to minus infinity. What is f of x?
0.
So this is true. This will be 0. This is the property of distribution function, cumulative distribution function. Limit, because random variable is taking values in real line. So it will be from minus infinity to plus infinity. It must assume values from minus infinity to plus infinity. So what it will be? X tends to plus infinity. What it will be?
1.
1. Is what about f of x? The nature of f of x, is it monotonically increasing function? f of x की वैल्यू धीरे धीरे बढ़ रहे हैं.
Yes, sir.
F of, so third observation is, I should not say observation, these are the properties. F of x is monotonically increasing. And fourth property is f is continuous from the right side. F is continuous from right side. from right side. This is not immediately seen. This is also simple, but I do not have time and I do not want to make things complicated. So I'll just simply mentioning the properties of the random cumulative distribution function. First three is very easy to see. So is it okay? Is it okay so far?
Yes, sir.
Yes, sir.
Now, so can you tell me what will be? So can you tell me what will be? So few more results. What will be probability that the random variable is taking the value xi using cumulative distribution function? Tell me using cumulative distribution function. What is the probability that the random variable is taking the value xi? So it will be f of xi. What is f of xi? F of xi is sum of all the probability at x equals to xi, sorry, this is what is f of xi? F of xi is sum of all the probabilities up to the point xi. So उससे हम लोगों को माइनस करने होंगे कि xi से थोड़ा पहले क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन कितना वैल्यू एज्यूम किए थे. So it will be f of xi minus f of xi minus 0. xi के थोड़ा पहले क्यूमुलेटिव डिस्ट्रीब्यूशन का फंक्शन क्या था और f of xi पे क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन का वैल्यू क्या था. इन दोनों को सब्ट्रैक्ट करेंगे. दैट विल बी टेलिंग यू द प्रोबेबिलिटी दैट द रैंडम वेरिएबल इज टेकिंग द वैल्यू x equals to xi. Okay, so this is another result. And what will be probability that the random variable is taking a value in a certain interval a less than equals to capital X less than equals to b? What is the probability that the random variable assumes the value from a to b, between a and b? So how to write down this set? So this will be probability. So x greater than equals to a. So this is a you look at you how did we consider cumulative distribution function? हम लोग ऐड करते जा रहे थे. So up to the point a, what is the total probability? From minus infinity to a, what is the total probability? That is f of a. That is f of a. What is the probability that the random variable is assuming value up to the point b?
F of b.
F of b. So यहाँ से minus infinity से b तक हुए f of b. So what will be the probability that the random variable is lying here?
F of b minus
F of b minus f of a. So this is f of b minus f of a. Okay. So these are the properties and results related to cumulative distribution function. So random variable are classified into two parts: discrete and continuous. Discrete case you have probability mass function, distribution function. Then for continuous case, same kind of results will be there. Whatever we are considering in discrete case, similar terminology and results will be there in case of continuous random variable. So let us quickly solve one problem so that you understand the concept. Example. So x is a random variable with probability distribution function, with probability mass function f of x equals to k into 2x minus 1. What is the possible values of x? X equals to 1, 2, 3 up to 12. What is the value of k? What is k? And what is the corresponding cumulative distribution function? What is the corresponding cumulative distribution function? Okay, so if you write down in this tabular form, so it will be xi and corresponding probability. So x equals to 1, 2, 3, 4, 5, so on up to 12. What are the corresponding weights or masses of each random variable? It is given according to the formula f of x equals to k into 2x minus 1. So what is the weight for 1?
K.
K. Then weight for 2?
3K.
3k, then 5k, then 7k, so on up to
23K.
23k. Is it okay?
Yes.
So what is the possible value of k? Sum of all the masses is 1. If this is a probability mass function, then sum of all the masses must be 1. Since x comma px is probability mass function, so sum of all the masses what is p of xi? This is basically short notation, probability that the random variable is assuming xi value. So this should be 1. So that will tell you k plus 2k plus 3k up to 23k, that will be equals to 1. You add it, you know the formula, and then you find out the value. K will be 1 by 144. Okay. So this is the value of k. So once you know the value of k, so now the probability mass function is completely known to you. X 1, 2, 3, 4, 5, 6, 7, 8 up to 12. And what will be the corresponding probability? 1 by 144, 3 by 144, then it will be 5 by 144, then 7 by 144, so on up to 23 by 144. So this is the probability mass function of the random variable. What will be the cumulative distribution function? हर एक random variable को assume, so probability cumulative distribution function will be the sum of all the probabilities up to that point. So this is probability mass function PMF. So cumulative distribution function CDF, cumulative distribution function. So it will be x equals to 1, 2, 3, 4, 5, 6 up to 12. And what will be fx? So what is f1? Sum of all the probabilities up to the point 1. So f1 will be 1 by 144. What will be f2? Sum of all the probabilities up to 1 up to 2. So it will be 144 plus 1 by 144 plus 3 by 144. So it will be 4 by 144. What will be f3? F3 is sum of all the probabilities up to the point 3. So it will be sum of 1 by 144, 3 by 144 and 5 by 144. So it will be 9 by 144 and so on. You have to complete it. So that will be the cumulative distribution function of this discrete random variable. Now, so cumulative distribution function can be used to obtain the probability of any event. Any event. So if I ask you now a question, what is the probability that the random variable assumes the value less than equals to 3.5? What is the probability that the random variable assumes the value up to the point 3 point up to 3.5? So what it will be?
14 by 140.
So you can use either probability mass function or cumulative distribution function. From there you can determine what will be the probability that the random variable assumes that value. Okay, so any question you ask, what is the probability that the random variable takes the value 12? What is the probability that the random variable takes the value more than 7.2? तो ये सारे आंसर आपको इस डिस्ट्रीब्यूशन फंक्शन से मिल जाएंगे. Okay. So we are here in discrete case, we will consider three important distribution. We are going to consider three. We are going to consider three important discrete distribution. One will be discrete uniform distribution. Then binomial distribution. And then it will be Poisson distribution. This P is capital P. Okay. So we are going to consider them, but not today. Okay. Next is continuous random variable. So again, for continuous random variable, we have probability density function. How the probabilities are distributed for continuous random variable. Okay. So a random variable which is assuming all possible values in a certain interval, that is called continuous random variable. And how the probability are distributed for continuous random variable. So it is given by this probability density function. Probability density function. So probability density function, you have a function f of x. Okay. So a function defined on function f of x defined on R is called probability density function, PDF probability density function, PDF, if and only if these two conditions are satisfied. F of x should be greater than equals to 0 for all x belongs to that interval I, and second one is total area under the curve should be 1. Integration over I f of x dx should be 1. Total area bounded by that curve and the interval should be equals to 1. If these two conditions are satisfied, then that function is called probability density function of the random variable. So if you try to deduce similar result what we did in case of discrete random variable, then can you tell me what will be the cumulative distribution function? So first, this is probability density function. Okay, so these two property must be satisfied. Then cumulative distribution function for continuous random variable. Cumulative distribution function. So f of x, again definition of cumulative distribution function is same. F of x is probability that the random variable assuming the value up to the point x. So what will be the total probability up to the point small x? So what it will be in case of continuous random variable? You have a continuous function. You have a certain interval a and b, or this interval you have a function defined, and remaining part it will be 0. You have to define the function, density function, in the whole real line. So in a certain interval it will be, sorry, it is not 0. In a certain interval it will be a curve, and then remaining part it will be 0, such that the total area is 1. Total area bounded by that curve is 1. It has to be 1, otherwise it will not be a probability distribution. It will not be a probability density function. You see, these are the two conditions has to be satisfied. So what is the total probability up to the point x? So area bounded by that curve up to the point x. So this will be integration minus infinity to x f of x dx. In discrete case, it was summation. In continuous case, it is integration. Okay. So this is called probability cumulative distribution function. So can you tell me the properties of distribution function? What is f of minus infinity? What is f of minus infinity? Same kind of result you will see.
0.
Limit x tends to minus infinity, f of x will be what? 0. Okay. Second one is, what will be limit x tends to plus infinity, f of x? So this will be minus infinity to plus infinity, f of x dx. What is that? Total probability, total area bounded by that curve. It is 1. If it is a density function, total area must be bounded by 1. Total area bounded by that curve must be 1. Okay. So it is 1. Again, you can see that f of x is increasing function, monotonically increasing. And fourth property, it will be continuous from right. In this case also it will be true, continuous from right. Okay. So now few more results. Can you tell me what will be the probability that the random variable x assumes the value from a to b, between a and b? A less than equals to x less than equals to b. What it will be? It will be a to b
Integral.
f of x dx. Okay. And what will be probability at a single point? What is the probability that the random variable x assumes the value a? So how can we write x equals to a? We can write x equals to a as a less than equals to x less than equals to a. You know it. So by definition it will be a to a f of x dx. So basically that tells you the area of a line. Area of a line. So what is the area of a line? It's 0. So in continuous random variable, if you want to find out the probability that the random variable assumes certain value, it will be 0. In discrete case it is not 0. In continuous case किसी एक वैल्यू पे एज्यूम करने का प्रोबेबिलिटी 0 होंगे. प्रोबेबिलिटी कब नॉन जीरो होंगे? जब रैंडम वेरिएबल किसी एक इंटरवल में वैल्यू एज्यूम करते हैं. ओके, सो दीज आर द ऑब्जर्वेशंस, दीज आर द फ्यू मोर प्रॉपर्टीज. ओके, so in this case we are going to consider what we are going to consider. We are going to consider some important continuous random variable, some important continuous random variable. This probability part is not small topic. It is very large topic. Whole syllabus can be devoted to study this part. It is very difficult which part to include, which part to exclude. So anyway, so we are going to consider normal distribution or bell curve or sigma curve, normal distribution, and then we are going to consider uniform distribution. Uniform distribution. Okay, so these are the three discrete random variable and two continuous random variable. Discrete random variables were discrete uniform distribution, binomial distribution, and Poisson distribution. Here in continuous case we have normal distribution and uniform distribution. We are going to consider these five in details. I will not be doing all the calculation. Sometimes I will be leaving it up to you. So we have to define few more things. The definitions of expectation and variance, standard deviation. Okay. So we have random variable. Okay, it is divided into continuous and discrete. So here discrete. Here we have continuous. Discrete case, what we have? We have PMF, probability mass function. Okay, we have cumulative distribution function. Here in continuous case we have probability density function, and then we have cumulative distribution function. Cumulative distribution function. Okay, PDF is given by f of x. Okay, CDF will be given by capital F of x, which will be minus infinity to x f of x dx, and here CDF will be cumulative distribution function in case of discrete random variable will be given by summation xi less than equals to x, probability at x equals to xi. So this is a CDF, and probability mass will be given by this pair xi and pi. Okay, so that is the probability mass function for some i's 1, 2, 3 up to depending on the number of values. So these are in short what we have considered so far. So now for discrete random variable and continuous random variable, we are going to consider certain results. It is known as expectation or mean. What is the weighted average of the random variables? Sorry, what is the weighted average of the output values of the random variables? Okay, in case of probability mass functions, we are going to consider weighted average of the xi, weighted average of xi, and in case of continuous random variable, we want to find out the center of mass of the function f of x. It is a curve. F of x is a curve. So center of mass will be a point. Only x coordinate will be there. Y coordinate we do not have to consider. We can easily find out what will be the y coordinate from the function. So in case of continuous random variable, expectation or mean will be telling you the center of mass of the density function. And in case of continuous, in case of discrete random variable, it will tell you the weighted average of the output values. So what is definition? Expectation definition. Expectation of x is summation xi into probability pi. So this is summation over I xi probability that the random variable x is assumed the value xi. So this sum is known as the expectation of the random variable x in case of continuous, in case of discrete random variable. In case of continuous random variable, it will be integration minus infinity to plus infinity x f of x dx. Okay. Next is variance. How much variance in there in the discrete random variable and continuous random variable? So this is expectation of x minus, so it is denoted as symbol mu. Expectation is denoted by the symbol mu. So expectation of x minus mu square, this is known as the variance. So what it will be in case of discrete random variable? It will be summation over I x minus mu, so xi minus mu whole square into pi. So if you write down one more line, it will be summation over I xi minus mu whole square probability that the random variable is assuming the value xi. So this is the definition for variance. In continuous case, it will be expectation. So let me write down var of x, variance of x. This will be expectation of same thing, x minus mu square. So what is this by definition? Minus infinity to plus infinity, x minus mu whole square into f of x dx. In case of discrete random variable, it tells you what is the difference between, average difference between mean and the probability masses. What is the average difference between the mean value and the other possible outputs, other possible xi? And in case of continuous random variable, where x tells you the moment of inertia of the function f of x perpendicular to the axis passing through the center of mass. So these are the notations and formulas which we are going to use. Mu for expectation, it is defined for continuous random variable and discrete random variable. Variance is for again discrete random variable and continuous random variable. And one more notation is there, standard deviation, and then I will finish the class. Standard deviation. So it is
Sir,
denoted by the
we have
sigma. Sigma is under root var x. I'll finish the class. Just 10 more seconds. Both the cases. Sigma equals to under root var of x, variance of x, positive under root. So this is standard deviation. Okay. Okay, today I'll stopping the discussion. We'll start from this point in the next class. So what we have to do basically, we have to find out what is expectation, variance and standard deviation for each of the density function and mass functions we have written. Binomial, Poisson, normal, uniform. For all of these distribution, what is the expected value or mean and what is the variance? That is what we are going to consider, and we are going to learn about this distribution, and we are going to solve few more problems. Is it okay?
okay, sir.
Okay. So I'll stop at this point. Please, you remember these definitions. Without these definitions, without these formulas, you will not be able to solve anything in this topic. Okay. So if you have any question, you can ask me. If not, you may leave the class.